we can check first if the orthomosaic has been developed properly. I go to the place where it was saved. I see the picture is almost 1 GB heavy. I open it. Might take some time to open 1 GB picture. Here is our images. The zoom is 4%. Let's see the quality by 100%. This is outside. I would say the quality is rather good. We have plenty of details, and this picture can be really used properly in qGis. I close, and now I go to qGis. That's the perimeter of the site. I display the site taken from Google Earth. It's a rather old picture. And now I insert the 2 digital elevation model under the orthophoto. I click add the raster layer. I select the 2 DEM, the DEM from the model and the DEM from the point cloud, and I select the orthophoto. I click open. Fine. Let's first analyze the orthomosaic. Takes some time to open it because it's a very heavy picture. Here it is. Let's confront it with Google Earth. You can see the difference. It's really relevant. Not only the picture that we have done is recent, updated, but the quality is much better. The drone orthomosaic is shifted, and it makes sense to orient properly the drone orthomosaic based on OpenStreetMap or based on Google Satellite. This is up to you. If you wanted to shift the drone images, you have to go to raster and georeference. You might find in YouTube a lot of tutorial how to georeference a picture. Let's see if it is also properly located in relation to Google Earth. Yes, it's not bad, I would say. Now we can take away those white border. It is very simple to do that on qGis. You click twice on orthomosaic, the properties appears. You select transparency, and here you add 1 layer, and you choose the white color, the value for the white color. Select on white. You get automatically this number 255, 255, 255 and 100. This we can take away. I don't know why it's there. Apply, and that's it. Voila. We can really now develop our site and work based on this orthophoto. Next step would be to develop the contour line. We have 2 digital elevation model, this done by the point cloud and this done by the model. Let's start with the DEM of the point cloud. This is the DEM. We developed the contour line. You go to raster, extraction, contour, and you choose the right digital elevation model from the point cloud. We want to display it every meters equidistance. The rest we keep it like that, and click on run. This might take a few minutes. This is done. I close and I check now the contour line. It's a temporary layer. You can see the contour line are rather complicated, not very nice. You could improve those contour line, but before improving it, let's see how the contour line created from the digital elevation model of the model look like. This is our digital elevation model from the model. I go to raster, same process, extraction, contour. This time I choose the model, again 1 meter equidistance, and okay. I just remembered that the model was smoothed several times, therefore the process should be much quicker. Voila, it's finished. Let's have a look. Those contour line looks much better than the previous one. Let's confront the two again. A very different result. So let's work on the contour line created from the model. I take away the contour line created from the point cloud. Fine. But even that, I want to clean those contour lines. You see, you have plenty of small islands which I want to avoid. So how to do it? For that, I need to create a column on qGis, given the perimeters. I click on calculator, and here I type perimeter. It's a wall number, and it's a geometry application. I filter it, dollar, and here perimeter. So first I want to check how many meters this is long. This is 54 meters long. So let's say I delete all the island smaller than 60 meter. I click here by the attribute table. I go to filter, and I select all the lines with less than 60 meter. 60 meter. And I have selected 413 features and delete. Fine. Now you see I don't have any island. Okay, now I want to make my contour line more smooth. I select again the contour line. I click on processing toolbox, and here I type smooth. I want to smooth by 2 iteration. Don't put a big number, maximum 3, because this will cause you to have a very heavy contour line file. Run, close. Now we can see the difference between the smooth contour line and the non-smooth contour line. This is the non-smooth contour line, and this is the smooth contour line. It looks better. So I take away that one. Here I have the smoothed one. Now I want to make it nice looking. There are some problems. For example, this is not good, this is not good. So I want to delete this part. I select the vertex tool, current layer, and I select all that, and I delete it. Might take some time. I save this file, make permanent as a shape file. I call it contour line row, and OK. Fine. Now again I need to clean that. Delete. Okay, this is done. Let's see if we have other problems somewhere. This is obviously also something which is not correct. Let's see what it is in reality. Okay, it might be a small hill. It's not a tree anyway, so we leave it. Anyway, it is outside of the site, so it's not really of interest. Fine. I save that shape file. Fine. Let's zoom in again to our site. It looks fine. Now let's style our contour line. Click twice. I have my style. If you don't know how to style the contour line, please check my tutorial about styling contour line. So now we have our contour line. The question would be now, how precise is my orthophoto and how precise are the contour line? The answer is that I don't know exactly, but what I can tell you that the orthophoto is much better than the Google Earth image that you can find, and pretty useful for site planner, and for the digital elevation model and for the contour line. Let's check part 6 of this tutorial, where we are going to confront both contour line of our drone images and of FabDem, and let's try to judge the quality based on the available information that you can find online. Thank you for listening.